Good evening, sir. You may please start the session, sir.
Okay, hi. Okay, sir. Thank you. So, hi, hello,
Thank you.
everyone. Thank you. So, hi, hello, everyone. Yesterday we were discussing about parametric forms and how you can differentiate when it comes to parameters. So, let us just try a few questions related to it. So, the basic method you all know. What happens in parametric form is that you have been given two variables, okay, in terms that have been written in terms of a parameter. Let us call it theta. So, the value of dy by dx. So the value of dy by dx is equal to y dash theta divided by x dash theta. Okay. So you differentiate y with respect to theta and you differentiate x with respect to theta and you divide both of them. That's how you do it. Great. Let us just try. So x is equal to a into theta minus sine theta. Okay. And y is equal to a into 1 plus cos of theta. So obviously it is asking you the value of dy by dx. Dy by dx. How would you do it? Can you tell me what is the value of x dash of theta? I need to differentiate this thing with respect to theta. What will it be? The derivative of x with respect to theta. Anyone? Anyone?
A of 1 minus cos theta.
A into 1 minus
1 minus cos
cos
theta.
theta.
1
Yeah,
minus cos
right.
theta.
Right? Just change your variables. Just change your variables. Earlier, what you used to do, you used to differentiate with respect to x, right? Now you are differentiating x with respect to theta. So in your mind, just keep all the things same that you used in differentiation. The thing that is changing is your variable. So now just tell me what is the value of y dash theta? Just a second. Uh, Bhavna, can you tell me what will be the value of y dash theta? How can you differentiate y with respect to theta? A is any constant. How would you do it? Anyone else? Shriram?
So,
Hmm?
so it could be a into minus sine theta.
Yeah, great. Right? A into minus sine theta because the derivative of 1 is 0. So 0
So,
plus minus of sine theta. So minus sine, right?
yes, sir.
So now the value of dy by dx is y dash theta divided by x dash theta, right? So it's minus a sine theta divided by a into 1 minus cos theta, right? So a
Yes,
and a
sir.
gets cancelled. You are left with minus sine
Minus
theta
sine
divided by 1 minus
minus
cos
cos
theta.
theta.
Fine. If you wish, you can leave the answer as it is. But if स्टाइल मारने का शौक है तो चलो स्टाइल मारते हैं. बताओ स्टाइल कैसे मारेंगे इसमें? What will you do? So you can just write this in half angle formula. So minus 2 sine of theta by 2 into cos of theta by 2. Okay. Whole divide by. How do you write 1 minus cos of 2 theta? Anyone? What is the value of 1 minus cos of 2 theta? Trigonometry.
2 sine square theta by 2. So,
Okay. It's 2 sine square theta, right? I've just asked 2 theta. So yeah, so if
okay,
in
sir.
place of theta I replace theta by 2, so it will be 2 sine square theta by 2. Right. Right? 2 sine square theta by 2. So what will happen is 2 and 2 will get cancelled and sine theta and sine theta by 2. Sine of theta by 2 and sine of theta by 2 will get cancelled. The final answer you'll get is minus cot of theta by 2. Fine. Is this correct?
Yes, sir.
Okay, great. So can you just tell me what will happen if I give you a particular value of theta? So for example, I tell you that the value of theta is 0. And at value theta 0, I am asking you the value of dy by dx. What would you do? So you have already found out your dy by dx. In this, you can just directly substitute your value of theta, right?
Yes,
Right?
sir.
So
Yes,
minus cot
sir.
of, okay, just a minute. Let us take it to be pi by 2. Because at 0, it won't exist. So for example, theta is pi by 2. So can you tell me what will be the value of dy by dx? Anyone? Minus cot of 0 by 2. So minus cot 0. What is cot of 0? Sorry. Minus cot of,
Yes, sir. 90.
no, it will be, no, it is pi by 4. So pi by 4. What is cot of pi by 4 equal to? Tell me. Cot of minus cot of pi by 4. What will it be?
1, sir. Minus
Minus 1.
Minus 1.
1.
Yeah. Yeah. Minus of 1, right? Great. Okay. So just one complex question related to this. Complex in the sense related to chain rule. So you have been given y is equal to a sine t and x is equal to a into cos of t plus log, that is natural log. So I can just write it ln of tan of t by 2. Okay, this thing's been given to me. So again, it is asking you what is the value of dy by dx. Can you just tell me what will be the value of y dash of t? See, the parameter over here is t. So I will differentiate y with respect to t. Okay, there is no theta over here. The parameter has been changed to t. Can you just tell me what will be the value of y dash t? Bhavna, Ashrita, the derivative of a sine t with respect to t.
Cos T, sir. A cos T.
Yeah,
A cos
a
T, sir.
cos t. Great. Let us try this one. This one looks little bit tougher, but it is actually not. So a can be taken out common. So you are left with cos t. What is the derivative of cos t?
Minus sin T.
Great. Over here, you have got natural log of tan of t by 2. Can you differentiate this thing directly without creating a web chart? The web chart takes really long time.
1 by
So since you
tan.
have
1 by
practiced
tan theta, tan theta, t by t, t by 2.
tan t by 2, okay,
Yeah.
multiplied by, great. So you have completed
Square.
your first level.
Yes,
Okay,
sir.
great.
Square
Secant
T by
square of
2
t by,
T
great,
by 2.
into 1 by 2.
into,
1 by 2.
great. Absolutely correct. So I hope all of you have got this, how it came. See, inside natural log, tan of t by 2 has been inserted. So it will be 1 by tan of t by 2. Okay. After that, it is tan of t by 2. So derivative of tan is secant square. So secant square of t by 2. After that, you have got t by 2. So derivative of t by 2 is half. So this thing, correct? Let us check it and try to see if this can be written in an easier form. Okay. So secant square of, so 1 by tan can be written as cos by sine, right? Cot. So cos of t by 2 divided by sine of t into. So this thing can be written as cos square of t by 2, right? And over here you have got a half also. So this will cancel. So in the denominator, you have got 2 sine t by 2 into cos of t by 2. This can be written as 1 by sine of t, right? Half angle formula. 2 into sine
Yes.
t by 2 into cos of t by 2. Okay. So my x dash t, my value of x dash t becomes a into minus sine t plus 1 by sine, right? Is this correct now, everyone?
Yes, sir.
Okay. Navneet, how are you?
Fine, sir. How are you, sir?
Fine. Great. So I just take this sine t common. In the numerator, I'll get 1 minus sine square t, right? Just take this sine t onto this side, so you'll get 1 minus sine square t. What is 1 minus sine square t? It is cos square, right?
Cos
So
square.
A into cos square t by sin.
Sin t.
Sin t.
Great. So now you have successfully calculated your value of y dash of t and your value of x dash. What would you do next? You can just
D-
like you need to
Yes.
calculate dy by dx. So just divide. Yeah, correct.
Yes, sir.
So your value of dy by dx, you can just divide. So in the top, you have got a into cos of t,
In
right? Divide by a cos square t into divided by sin t. So this sin t can go up
by
and it will become like this, right?
90.
It is divided by sin t, so sin can go up. So it becomes tan of
We
t,
can just tan up.
right? Okay, so I'll just write it again with brackets.
Mhm.
This is my final answer.
Let's be it.
Fine. Got it, everyone?
Yes, sir.
Yes, sir.
Okay. Okay. So a is any constant, and you have been given y is equal to a raised to t plus 1 by t. Okay. And you have been given y. Okay. So this was y. Y is equal to a raised to t plus 1 by t. And x has been given as t plus 1 by t whole raised to a. So a is again any constant. So again, it is asking for dy by dx. So let us do dx by dt first because it looks easier. Can you tell me which function is inside which function? Which function has been inserted inside which function? It is t plus 1 by t raised to a. So like we generally used to do. So it is x plus 1 by x whole raised to a. A is any constant. So can you tell me which function is inside which function? Or can you directly do the derivative of this thing? No one.
Sir, is it one? Derivative of
One. No. How will it be one? Like, can you tell me?
Sir, 1 by 2.
Hmm. 1 by 2. No. Think again. Okay, so just tell me, like, for example, I give you your y. Okay, I give your y as x plus 1 by x whole raised to a. Can you just tell me which function is inserted inside which function? If I ask you to calculate dy by dx, which function has been inserted inside which function? Like, it is really basic one. It is like a normal use of chain rule. Can you see any chain rule applied over here? Anyone? Gayatri, Vignesh? No.
Sir,
So,
12
like,
into
it is really basic.
that is it.
Hmm? Tell. Okay, so in place of A, I give you any number. Okay, so if you're getting confused, I will give you some number. Any number, 100. Okay, so you've got x plus 1 by x raised to 100. So which function is inside which function? In place of which function? Tell me. Like, I don't know why you're getting so confused. Inside x raised to 100, what function is there?
X one by
Constant 1 by x.
Yes, right?
yes, sir.
So I require you to do the same thing in t. So just change your variable from x to t, and you'll get the correct thing over here. So let us give it a try now. So you have been given t plus 1 by t raised to a. Okay. So in t raised to a, t plus 1 by t has been inserted. So I approach from the outermost side. The first function that I meet is t raised to a. What is the derivative of t raised to a? I am differentiating it with respect to t.
A into t
A-
raised to a minus 1, sir.
Yeah. See, a is any constant, any real number. Okay. A is any real number. So what will be the first term that I write over here?
A into t plus 1 by t whole raised to a minus.
Yes. Right. See, inside x raised to a, x plus 1 by x was inserted. Right. So over here, just change your variable from x to t, because now the derivative, the differentiation is being done with respect to t. Great. So you complete this level, you moved inside. What will be the derivative of t plus 1 by t with respect to t?
1, sir.
Okay, 1 plus
Log.
derivative of log. No. What is t 1 by t? Like 1 by t can be written as t raised to minus 1, right? What is the derivative of t raised to minus 1?
1 by 2.
No. What is the derivative of t raised to minus 1 with respect to t? Minus 1 is also a constant, right?
Minus 1 into
Yes.
t raised to minus 2.
Minus 1 into
Great,
t plus
right? So this can be written as minus 1 by t square. Do you agree? T raised to minus 2 can be written as, okay, let us try it now. So 1 plus minus 1 by t square. Great. So this thing can be written as a into t plus 1 by t whole raised to a minus 1 into 1 minus 1 by t square. Great, correct. Now the second part. So you have been given your y as t plus 1 by a raised to t plus 1 by t. So again, I need to calculate my dy by dt. So that is y dash of t. Can you tell me a raised to t plus 1 by t? Okay. So you have got a raised to t plus 1 by t. Which function is inserted inside which function? A is again any constant. Okay. So a raised to t plus 1 by t. Or do you need to require some special form of differentiation for this one? Is there something special that you need to do?
Log, sir. Log
Okay,
applies.
great. Okay, great. You can go for logarithm, but without logarithm also you could have done it. I can tell you how. See, do you know the derivative of a raised to x? We have done, we have proved this. What is the derivative of a raised to x? When we were learning logarithmic differentiation, so I had given you the proof of the derivative of a raised to x. Okay, great. So I'll just revise that again over here in the right hand side. So dy dx of a raised to x. Anyone remembers what was it? It was a raised to x into ln of a. Okay. We had done it when we were studying about logarithmic differentiation. So now can you see this and tell me which function is inserted inside which function?
Inside a raised to x, t plus t 1 by t is
Okay.
included.
Okay. So basically inside a raised to t, t plus 1 by t has been inserted. Is
Yes,
this right
sir.
now? Right?
Yes.
So you
Yes.
approach from outermost side. The first function that you get is a raised to t. The derivative of a raised to t is a raised to t into ln of a. So can you tell me what will be the first term that comes over here?
A raised to t plus 1 by t into ln a.
Great. So I complete my first level. I moved inside. I met t plus 1 by t. What is the derivative of t plus 1 by t? We have just calculated it. The derivative
One.
of t plus 1 by t is 1 minus 1 by t square,
Yes, sir.
right? Right?
Yes, sir.
Okay. So I just hope all of you remember this a raised to x. So how did we prove this a raised to x was? Like we have done it 2 classes back or 3 classes back, I don't know. Like it was just when we were learning about logarithmic differentiation. So we had given a proof of this. So what you do is you take logarithm on both sides. Okay. Then you differentiate. So in the right hand side, x into ln of a. Ln of a is again a constant. So it becomes something like this. So your y dash is basically y into ln of a. So just writing it back again. So it is a raised to x into ln of a. Fine. See, I gave you a very small proof of this thing. So when y is equal to a raised to x and the derivative with respect to x is a raised to x into ln of a. Fine. Okay. So now just one thing is left. I have already calculated dy by dt and I have already calculated dx by dt. I just need to divide both of them. Okay. So dividing both of them, I'll get a raised to t plus 1 by t into ln a into 1 minus 1 by t square. Okay. Whole divided by a into t plus 1 by t raised to a minus 1. Again into this thing, right? 1 minus 1 by t square. So 1 minus 1 by t square will get cancelled and this will be my final answer. Right? Right. So this is my final answer. A raised to t plus 1 by t.
Plus 1 by
And
t
so I have a
by
a in division. So I can write it like minus 1. Right?
minus 1.
Power minus 1 into ln of a whole divided by t plus 1 by
A
t raised to a minus 1. So this is like a typical 5 marks question that may come for your board exams. So this will be your final answer in terms of P. Anyone, any doubt in this question? Okay. So yesterday we were discussing about how in some of the questions, instead of approaching the question directly, sometimes you may need to involve a parameter in that. Okay. Instead of going to the question directly, you may need to insert a parameter in that in order to do the question. So you have been given a question like this. Okay, just a minute. Okay. So again, in this question, it is asking you what is the value of dy by dx. So if you go about and directly see it, it is an implicit function, right? Every one of you can see it is an implicit function, right? X and y are not separated. So how would you differentiate it if not for the parametric form? So for a time being, you can just forget that parametric form exists. And if you go about differentiating it, how will you do it? So you can apply chain rule in this case. Again, you will apply chain rule over here. And again, you will apply chain rule in this case and you can do it. Okay. So, but it will go really long. So what could be the next method? What is the other thing that you can think of? See, it is square root of 1 minus x cube, right? Square root of 1 minus x cube. So you can just treat your x cube as cos square of theta. Okay. And you can treat your y cube as some parameter. Okay, so let us not take it for the time being. Let us take it any angle z. Okay, what will happen? So you can just see it. Square root of 1 minus cos square theta. What is 1 minus cos square theta? 1 minus cos square theta is sine square theta. So this
Sine
thing will
square
become
theta.
sine of theta. So this
Sin
will
square
become
theta.
sine of theta, right? Similarly, square root of 1 minus y cube. Okay. So y cube is sine square of z, right? Sine square of z. So this thing will become cos of z, right?
Yes, sir.
Cos of z. So the same thing over
Yes.
here. Your right hand side, x raised to 3 by 2. X raised to 3 by 2 is basically cos of theta, right? And your y raised to 3 by 2 is, how much is it? Y raised to 3 by 2. So it is sine of z. So now you have just got your two parameters, theta and z. Okay. And in these two parameters, you will need to resolve your equation. So your final equation will be sine theta plus cos of z is equal to cos theta plus sine z. Okay. So I can just take it out this side. So can you tell me sine A minus sine B? What is the formula of sine A minus sine B? So I've got sine theta minus sine Z. So it will be 2 sine A minus B by 2 into cos of A plus B
Cos
by
of
2.
A plus B.
This thing can be written as minus 2 sine and again a sine, right?
Sin.
Right? Correct? So you can see this 2 will get cancelled and this sine of theta by 2, this will also get cancelled. So what will you be left with? You will be left with minus 1 is equal to tan of theta plus z by 2,
Theta
Theta
plus
plus z by 2.
right? So tell me what will be your next step in this one? So you can just differentiate this whole thing with respect to x, okay? If you differentiate this whole thing with respect to x, your left hand side will be 0. Okay. See, actually, like this was a tougher question to apply. So fine. So let us just do it directly. Okay. So can you tell me square root of 1 minus x cube? So which function is inserted inside which function? You have got square root of 1 minus x cube. So which function is inserted inside which function?
1 minus x cube inserted in the root x.
Great. So will you be able to differentiate this? Right? You will be able to differentiate this. See,
Yes,
actually,
sir.
like I wanted you to I wanted to give you an example, but this example was like really complex. So fine. So let us just skip it for the time being. Okay. The example went really complex and it was even tougher to solve it in the parametric form. So for the time being, you can just forget it and we'll just continue and Okay, so moving ahead, today we'll discuss about second order derivative. So what is meant by second order derivative is, as we have discussed earlier also. So for example, you have got a function y is equal to f of x. Okay. So you differentiate it, you get f dash x. F dash x denotes the slope of the curve at any point. Fine. It denotes the slope of the curve at any point. If you differentiate f dash x again, okay, if you differentiate it f dash x again, so what will happen is it will be d by dx of this dy by dx, right? This thing is also denoted like d square y by dx square. Okay, so it means 2 times the derivative of y. So this thing will denote slope of f dash at any point. So basically, second order derivative means that you need to first take the derivative, you calculate dy by dx, then you again do the derivative and you get at the point f dash x. So fine. So let us just look at a few questions related to it. So let us try the easy ones first. So I've got y is equal to sine of 3x. So can you tell me what is the value of dy by dx? What is the derivative of sine of 3x?
3 cos 3x.
Great. 3 into cos of 3x. So your value of d2y by dx square is basically the d by dx of dy by dx. Fine. So now you need to differentiate 3 times cos of 3x. What will it be? So 3 will come out common and you now need to differentiate cos of 3x. What will it be? Can you tell me? What is the
Minus
derivative of
3
cos of 3x?
sine 3x.
Hmm.
minus
Minus
3
9
sine
Right. So it becomes minus 9 times sine of 3x.
minus
Yes.
19 minus 3.
Okay, great. Over here, dy by dx. What is your value of dy by dx?
3x square plus 2x plus 1.
3x square plus 2x plus
Hmm.
1.
Right? 3x square plus 2x plus 1.
Yes, sir.
So
sir.
if I ask you to differentiate it 2 times, so now you need to differentiate your dy by dx. Can you tell me what will be your second derivative?
6x plus
6x
2.
plus 1
6x plus
2,
2
how
sir.
sir.
much? 6x plus 2. Great.
Sir.
2.
So yeah, so this is what we call the second order derivative. It gives you the slope of the derivative. It is useful at many places, like as we had discussed when we were discussing the common syllabus to both JEE and NEET students. It tells you the maximum or minimum points, and we used it at many places in when we were studying about maximum minimum in relations and functions also. Okay. So your y has been given to you as x cube into ln of x. Can you tell me what is your value of dy by dx? How do you differentiate x cube into ln of x?
Product of the
Product rule. Great. So you differentiate your first function first. You keep your second as it is. After that, you differentiate your first function. Sorry, you keep your first function as it is and differentiate your second function. So this thing
yes,
will
sir.
be 3x square into ln x plus x square, right? Again, I ask you to differentiate dy by dx now. So you have got x square. So let us do that x square first. So it will be 2x plus. Now you have got 3 into x square into ln x. What is the derivative of x square into ln x? How will you do it? X square into ln of x.
Sir, it could be only product rule.
Yes, great. Product rule. So you differentiate your first function, keep second as it is, plus keep first as it is, differentiate your second function,
1 by x.
right? Right?
Yes, sir.
Correct? Plus, so this will be 3x plus 6x into ln x plus 3x, right? So this thing becomes 6x into ln x plus 5x, right?
Yes, sir.
Okay, great. So what is your value of dy by dx? Sine of ln x.
Cos of ln x plus sine x
Cos of
One
ln x, tell me, cos of
Sine
ln
into
x
1 by x. Sine into 1 by
into
x.
1 by x. So this thing can be written as cos of ln x divided by x, right? Now, how do you differentiate this thing? How will you differentiate cos of ln x divided by x? So two functions are in division. How will you do that? When you have got two functions that are divided to each other, what was the formula for applying the rule? Division rule.
denominator square.
Okay, great. You get the denominator square in the bottom.
First
So
term derivative, second term
Derivation
constant.
and
minus,
second term derivative into first term, sir.
First term constant.
great, great, correct. So over here you will need the derivative of both your numerator and your denominator. So can you just tell me what is the value of u dash? What will be your derivative of the top? Your numerator over here is cos of ln x. What will be the derivative of numerator? Cos of ln x. The derivative of cos of ln x.
U dash 1,
How much?
1, sir.
Minus ln x, sir.
Minus
Nee,
sine
I
of
am asking you.
ln x. Minus sine
I am
ln x.
asking
minus
you
sine of
cos of
ln
ln
x
x.
into 1 by x.
1 by x.
Minus sine of ln x into
Into
1
Into
by x.
1
1
by
by
x.
x. Yes, sir.
Right. Great.
Alright.
Correct. So let us give it a try now. So I have got this formula. So first I'll take the derivative of the top and keep my bottom as it is minus. Now I'll do the other way around. So I'll take this thing and keep my numerator as it is, whole divide by denominator squared. So this x and x will get cancelled. So my final value that I'll get is minus
Minus
sine of
sine
ln x
ln x minus cos of ln x by x square.
right? Right? Great. So, like, in order to find the second derivative, you don't really need to do many things. All you need to do is that you should know how to apply chain rule properly. So, can you tell me what is the value of y dash? The derivative of ln x. What is the derivative of ln x? So, you have got ln of ln x. So, which function is inside which function?
So 1 by ln x into 1 by x.
1 by ln x into 1 by x. Great. Right? Because in this function, ln x has been inserted inside ln x. So if you approach from outermost side, the first function that you get is yx. So it should be 1 by ln x, the first term. And after that, you complete this level, you moved inside, you met ln x. Derivative of ln x is again 1 by x. So yes, correct. So now you have got 1 by x into ln x, right? 1 by x into ln x. So this thing can also be written as x into ln x raised to minus 1, right? Now I ask you to differentiate this derivative. So it can be written, it is also written as y 2 times. Okay. So 2 dash would mean two derivatives. So can you differentiate x into ln x raised to minus 1? How will you do that?
So ln x minus. So ln x minus 1, sir.
ln x plus 1, sir.
ln x minus 1.
Plus 1.
Why will it be ln x minus 1? Think it is x multiplied by ln x raised to minus 1. So x multiplied ln x. So like, can you just tell me, Vignesh, what is the flow chart of this thing? X into ln x whole raised to minus 1. So which function is inside which function? Can you think?
Inside x raised to a x ln x is inserted, sir.
Okay, so inside x raised to minus 1, which function is inserted?
X ln x.
Yes,
Great,
sir.
x and ln x, right? So you approach from outermost side, you met x raised to minus 1. What is the derivative of x raised to minus 1?
Minus
Minus
x
1
raised
x raised
to
to
minus
minus 2.
Minus x raised to minus 2, right?
Minus.
So
Yes.
it is basically
sir.
minus 1 by x square. So what will be the first term that I write over here?
Minus x
1
ln
by
x whole raised to 1 by minus 2.
Great,
2.
right? Minus of x into ln x raised to minus 2. Great. I complete this level, I moved inside, I met x into ln x. What is the derivative of x into ln x? How do you differentiate this?
Product rule.
Product
Yeah,
rule.
apply product rule. So x into, you differentiate your second function,
1
or
by x
either you can do
plus
your first one plus 1 into ln x, right?
1
1
into
into
ln.
So this thing becomes 1 plus ln x, right?
Yes, sir.
Whole divided by x ln x whole square, right? I've
yes,
just
sir.
written this minus 2 in the denominator. Okay. Okay, great. So fine. So it's been given to you that y is equal to uh, a into sine of omega t plus phi. Okay. A, omega, and phi are real constants. Any real constants, okay? Any real numbers. So over here, all your variable is t. Okay. Your variable is t that you have. So I am asking you, what is the derivative of y with respect to t? Can you tell it? Can you tell me? So inside sine, omega t plus phi has been inserted. Okay, so let us change it to x now. X. If you're getting too confused. So I'm asking you, what will be the derivative with respect to x? Right? See, a, omega, and phi, just treat them as any real number. Can you tell me what will be the derivative?
A
So
cos of x plus pi
phi into, tell me, into, will I get something else?
omega.
Into omega, right? Yes, correct.
Omega.
So this thing can be written as
Yes.
a omega into cos of omega x plus
Cos
phi,
of omega.
right? Can you tell me what will be the value of the second derivative? What will be the value of second derivative? So a omega comes out as constant, right? Now you need to differentiate cos of
Sine
omega x plus phi. So it will be minus sine omega x
Minus
plus
sine
phi.
of omega x
pi
plus pi into
pi
omega.
That's it. Into omega. Great.
into
So
omega.
this thing can be written as minus a omega square into sine of omega x plus
Sine
phi.
of omega x plus.
Phi. Okay. Correct. So basically, what happens is, I am not sure which topic have you reached in physics currently. Have you reached SHM, simple harmonic motion? Okay, so if you have
No,
not
sir.
reached that topic, so okay, great.
Yes.
Okay, not an issue. So what happens in simple harmonic motion is that any real harmonic motion can be represented using this equation.
T sin
Fine,
into omega t plus
fine. X is your displacement from your origin. So any simple harmonic motion can be represented like this. So when you take its second derivative with respect to time, so can you tell me, you differentiate displacement? See, you differentiate displacement with respect to time, you get velocity. If you differentiate velocity with respect to time, what will you get?
Acceleration.
Great, acceleration,
Acceleration, sir.
right? So if you differentiate x with respect to time two times, okay. So what was happening over here? You were getting minus a times of omega square into sine of
sin of
omega t plus phi,
omega
right?
square by
Right? So this thing, this quantity basically represents your acceleration. Okay, your acceleration of the particle. So you can just directly see that your acceleration can be represented as minus of omega square of x at any point. Fine. Can you
okay.
see it? Right? At any value of x. Or you can see any value of t. You can say any value of t, or you can say any value of x. Right? In other words, okay, in other words, you can also say that whenever you get an equation like this, whenever you get an equation like this, so this equation, you can just take this omega square out on this side. Whenever you get some equation like this, the solution of this equation will always be a simple harmonic curve. So the solution of this thing will always be of this form.
T sin omega square.
Okay.
Okay.
So it is useful for you in many cases. It is useful in many cases. In physics, it will be useful. What will happen is that you will be given an equation. Okay. So for example, like in differential equations also, it will be useful many times. What will happen is that you will be given a differential equation of the movement of a particle. So for example, I tell you that a particle moves like this. Okay, it follows this differential equation. So you will immediately come to know from that that the particle is following the sine curve. It is following simple harmonic motion. Fine. Okay. So okay, let us give it a try in a similar question. So you have been given y is equal to 5 cos x minus 3 sine x. Okay. Okay. And now it is asking you what is the value of d2y by dx square plus y. The value of d2y by dx square plus y. Can anyone tell me what will be the value of this thing? Okay, so for that you would just need to change your y a little bit. So you can see if your y has been represented like this. Okay, so 5 square plus 3 square. So 25 plus 9, 34. So if I keep it something like this, 5 by 34 into cos x minus 3 by 34 into sin x whole into 34. I can write it like this. Is this allowed? Square root.
Yes,
Okay.
sir.
So what I do is I treat my 5 by square root 34 as some value sine of theta. Okay. So my 3 by square root of 34 will automatically become cos of theta, right? Because cos square theta plus sine square theta is 1. So 25 plus 9 is 34. So it will become like this. So I can write my y as square root of 34 into sine theta cos x minus cos theta sin x. Can you tell me which formula is this? Sine theta cos x minus cos theta sin x. Does it look familiar? Sin A cos B minus cos A sin B.
Yes, sir.
Sine,
Yes,
what does
sir.
it look like? Tell me.
Sine of A minus B.
Right. Sine of A minus B. Right? Right? So your y basically becomes, your value of y becomes y is equal to square root 34 into sine of theta minus x. Sine of theta minus x can also be written as minus sine of x minus theta, right? Sine of minus theta is, what is sine of minus theta? Sine of minus theta.
Minus sin theta, sir.
Yeah, minus sine theta. So I have just taken this minus outside and I have written it as sine of x minus theta. So do you compare this thing? Theta is again a constant, right? Because the value of sine theta has been given to you as a constant value. So theta will be a constant value. So your y is given to you as, do you realize that these and this is the same thing? A sine omega x plus phi, right? This thing and this thing have the same meaning, right? Because I told you that A omega and phi are just real numbers. So can you tell me what is your value of omega from here? Your value of omega?
1.
One,
Right?
sir.
Omega is 1, right? So the differential equation that earlier we had given was that 2 times derivative, okay, plus omega square of y is equal to 0. So omega is 1, so omega square is also 1. So in this case is equal to 0. So d2y by dx square plus y is equal to 0. So the value of this thing is equal to 0. This is my answer. See, it was like it looked tough because there was this little substitution required in order to change it into this form. If you have longer equations related to x, okay, if you have like 100 terms related to cos x, sin x, all of that, so this thing will become a lot easier to solve. Since these were only two terms, so you could have said that, sir, we can differentiate it really easily. But if you have many such terms, then it will be difficult. Okay. Now let us see how to differentiate parametric form. How to take the double derivative of parametric form. Okay. So again, what is parametric form? You have been given y as a function of theta. You have been given x as a function of theta. Now I am asking you to, so obviously you have calculated your value of dy by dx. Okay. Your value of dy by dx was y dash theta divided by x dash theta. Okay. So you can differentiate your y with respect to theta and your x with respect to theta. And you can get your dy by dx. Now I am asking you your value of d2y by dx square. Okay. So d2y by dx square basically means your second derivative of y with respect to x. How would you do that? So this thing basically means your d by dx of dy by dx. Fine. Dy by dx. How will you do that? So again, you can apply chain rule. If you apply chain rule, what will happen? So I divide my both numerator and my denominator by theta, d theta. So it will be d by d theta of dy by dx whole divided by dx by d theta, right? Something like this. So my denominator is really easy to think of. My denominator is x dash of theta. What is my numerator? It is d by d theta of dy by dx. How will you take the derivative of dy by dx with respect to theta? How will you do that? You need to differentiate your dy by dx with respect to theta.
side couldn't be y dash theta.
Why? No. See, your dy by dx is already y dash theta by x dash theta. How will you differentiate this thing with respect to theta? Right? So you need to differentiate, you will need to apply your division rule, right? Because your numerator and your denominator both are functions of theta. So you will need to apply the division rule over here. Fine. Okay. So fine, then let us just directly move on to a question related to it. So you have been given x is equal to a into cos t plus t into sine of t. Okay. And your y has been given to you as a sine t minus t cos t. Okay. And now it is asking you the value of dy by d2y by, right? So it will be minus sine t. How will you differentiate t into sine of t? You can apply product rule. So 1 into sine of t, right? Plus t into cos of t, right? So this sine t will get cut. It becomes at into cos of t. Okay, great. Now moving ahead to y dash of t. So it becomes a into cos t minus 1 into cos t. Okay, plus t into minus sine t. Do you agree with this? I've just taken one derivative at a time. So this final term becomes this cos t gets cancelled. So it becomes a into at into sine t. This is your y dash t. So in order to calculate dy by dx, all you needed was y dash t by x dash t. So it becomes, how much is it? Tan of t, right? Just dividing these two things, tan of t. Now in order to calculate d2y by dx square, you need to differentiate dy by dx with respect to x. So again, it can be written as d by d theta of d by dt of dy by dx divide by dx by dt. I have taken this dx to the denominator. So it is basically d by dt of tan of t, right? My value of dy by dx is tan t. Whole divide by dx by dt. What is my value of dx by dt? It is at into cos t. Can you tell me what will be the derivative of tan of t? The derivative of tan t?
Secant square t.
Secant square t. Okay. Divide by at into cos t. Right. Great. So this cos can go up again and become secant. So it will be secant cube of t divided by at. This is my value of dy by dx. d2y by dx square. Okay. So fine. That's it for today. So I hope all of you will just come revised with this thing about how to take the double derivative in case of a parametric form. And tomorrow we'll be discussing questions related to it. Fine. Sir, can you please end the class?
Yes, sir. Thank you, sir.
Thank you. Thank you, ma'am.